To explain the concept of mission synthesis, let's take the example of washing machines. Like most products around us, washing machines contain sensitive electronic components. Manufacturers must make sure these survive the vibrations experienced during the life cycle of the product. Traditionally, there's different ways to verify this. You can test the performance of the products against set standards. Disadvantage is that in many occasions these standards are not tuned to specific products or their use case, risking under or over certification. Second approach is to actually test the product against real life usage. Of course, one cannot perform a test having the washing machine run for 10 years on a shaker system. A much shorter accelerated test needs to be defined, which applies the same damage potential to the electronics in, for example, only 8 hours. This is exactly what mission synthesis is all about. First off, manufacturers have to think about the different types of vibrations that the products will undergo in its lifetime, the different missions, so to speak. Let's apply this to our washing machine. It undergoes vibrations due to the transportation from the factory to the local store. This is a random type of vibration. Next, the washing machine might accidentally be dropped while unloading from the truck, subjecting it to a shock type of vibration. And of course, the washing machine will be operating for a number of years, which has more of a sinusoidal type of vibration, for instance, during the spinning cycle. Each of these conditions, or missions, will partly contribute to the total damage that might finally make the electronics fail. The process of mission synthesis will take a measured sample of each of these conditions and calculate their partial damage contribution. By multiplying each of these with their occurrence, for instance, 10 times the transportation plus 5 times dropping and washing 4 times a week during 10 years. As such, the overall damage is calculated and converted into a synthesized test profile that can be sent to the shaker system or used in simulation. Running this accelerated test for 8 hours will have the same effect on the electronics as using it for a full 10 years in real life. If the electronics still work properly after this test, they can be certified and accepted in a quality procedure. Using the mission synthesis approach, manufacturers can define an accelerated test that accurately represents the vibrations their products will undergo in real life. Of course, the approach can be applied in many industries. For instance, a truck on the German Autobahn requires different parameter sets than the same truck in a mining condition. Thanks for watching, and visit our website for more information.